if f of x equal to a power x and x belongs to R, a greater than 0, then we show that the f of x log a, the first principal. Therefore, here hs tends to 0, f of x plus h minus f of x divided by h equal to a power x plus h minus a power x divided by h. Therefore, actually here condition is h not equal to 0, f of x plus h divided by f of x divided by h equal to a power x plus h minus a power x divided by h. What is the condition? A power x. So we are replaced to next place a power x plus h equal to a power x into a power h minus 1 divided by h. Therefore, a power h minus 1 divided by h log a as h tends to 0. Therefore, f of x equal to a power x log a into d by dx of a power x equal to a power x log a. But here f of x equal to a power x log a. Here log a is multiplied to a power x. Therefore, we are applied to the d by dx of a power x equal to a power x log a. This is a condition. Final value will get the a power x equal to log a. And the same way, here given x belongs to R, f of x equal to a power x, a greater than 0, this is a condition. And the f of x, a power x equal to log a, d by dx of a power x equal to a power x log a. So next one is, if f of x equal to log x, so here x greater than 0, this show that f dash x equal to 1 by x will be equal to, we are going to prove that this is a principal. Therefore, f not equal to here, especially we are observe here h not equal to 0, this is a condition. Therefore, f of x equal to log x, x greater than 0, this is a condition. Same way here f dash of x plus h minus f of x divided by h equal to f dash of x equal to 1 by x by, this is a principal. Here given condition, must and should we are going to prove that here f of x plus h minus f dash of x. Therefore, here h not equal to 0, f of x plus h minus f of x divided by h, they are equal to log of x plus h minus log x divided by h equal to here log of x plus h minus log x divided by h. What is the value? Here we are apply h not equal to 0. In case we will get h equal to 0, this condition is not defined. Therefore, 1 by h equal to log of 1 plus h by x equal to 1 by h by x log of 1 plus 1 by h equal to. Therefore, 1 by x log of 1 plus h by x whole power x by h. Put here, once observe here, x by h or either h by x, two terms is there. The two terms we assume that values here, put h by x equal to z, z extends to 0. The same condition is h tends to 0. Therefore, here z tends to 0, h tends to 0. Therefore, log of 1 plus h by x whole power x by h equal to log of 1 plus z whole power 1 by z gives rise to log e equal to 1, z extends to 0. E x by is reciprocal of 1 by z. Yes, log e equal to 1, z extends to 0. f of x plus h minus f dash of x divided by h. Why? Because here above equations we are represented 1 by 1 plus z whole power 1 by z. We represented f of x plus h minus f dash of x divided by h is tends to 1 by x as to h tends to 0. Therefore, f dash of x equal to 1 by x for each of x greater than 0. d by dx of log a equal to log x equal to 1 by x. So this is the condition. What is the condition is given f of x equal to log x, x greater than 0.
Next topic is especially in differentiation, one small some topics of proofs is there. This formulas, all problems we are going to prove, right? This first one is, if f of x equal to e power x into x belongs to R, then show that f dash of x equal to e power x by the first principal. So what is the meaning of the will be discussed. If f dash of x equal to e power x, what is the formula? We know that differentiations of dy by dx equal to e power x equal to e power x. So this is a formula, we know that well. But here f of x equal to e power x, where we know that the formula, the standard formula, f of x plus h minus f of x divided by h equal to e power x plus h minus e power x divided by h equal to e power x into e power h minus 1 divided by h. So this condition limits, we are applying limits h tend to 0, h tend to 0, limits h tend to 0, where f of x plus h minus f of x divided by h, where equal to here e power x, what is the, we are applying here limits e power x into limits h tend to 0, where e power h minus 1. So what is the f of x? 1. What is the f of x plus h? E power h. Therefore divided by h equal to e power x into 1. Therefore here, once observe here, e power x and this total value h tend to 0. h tend to 0 is nothing but e power 0. So e power 0 is nothing but 1 minus 1. Here 0. So totally this value is totally not defined, is a clear point. Right? Here, therefore e power x is there. Therefore e power x into 1 is nothing but we'll get e power x. Therefore, what is the saying of f dash of x? Here f dash of x here, f dash of x equal to e power x. Therefore, here what is the x value? Belongs to real numbers. So belongs to real numbers. Therefore, dy by dx of the e power x equal to e power x. So this is the formula, this is the proof. So especially if f dash of x equal to e power x equal, formula is, we know that dy by dx of e power x equal to e power x. So this is the formula. Next will be discussed. Next one more formula we are going to prove.
Next topic is d by dx of the cos x. We are going to prove. How do we get to proof once we will listen? So d by dx of the cos x. So d by dx of the cos x. How do we represent on the, we are going to prove that d by dx of cos x equal to minus sin x. Before this formula is d by dx of the sin x equal to cos x. So this one already we have discussed. This is a basic concept. But we are going to prove d by dx of the cos x. So the d by dx of the cos x equal to d by dx of sin inverse of pi by 2x, pi by 2 minus x. This is the first quadrant. Pi by 2 minus x is the first quadrant. Therefore, cos of pi by 2 minus of x into d by dx of pi by 2 minus of x. We are applying here uv formula. Therefore, we will get minus sin x. Therefore, here d by dx of cos x equal to minus sin x. So this will get value, but this proof is d by dx of cos x equal to minus sin x. Same way, once again we will be discuss. Remember, d by dx of cos x equal to d by dx of the cos x will be represented on d by dx of the sin of pi by 2 minus of x. Therefore, cos of pi by 2 minus x d by dx of the, and the same time pi by 2 minus x. Therefore, here condition is sin of pi by 2 minus x is the first quadrant. Therefore, first quadrant sin is the positive value. Therefore, cos of pi by 2 minus x into d by dx of the pi by 2 minus of x. Wherefore, cos pi by 2 minus of x is nothing but sin x. Where pi by 2 minus of x is nothing but, these we are applied differentiation. There pi by 2 is nothing but 0. The same way, minus x is nothing but 1. Therefore, minus 1 into sin x is nothing but minus sin x. Therefore, d by dx of cos x equal to minus sin x. Therefore, d by dx of cos x equal to minus sin x. This is the final value will be get. And the same way, similarly, will be discussed d by dx of cos x equal to similarly y equal to tan x, y equal to tan x. Therefore, x belongs to r. Therefore, here y equal to tan x belongs to r. Here 2n plus 1. Therefore, z belongs to r. These must and should. Therefore, n value belongs to z. Must and should integers, n values. Same way, y equal to tan x, sin x divided by cos x. Tan x represents as sin x by cos x. Therefore, dy by dx of 1 by cos square into x into cos x dy by dx of sin x minus sin x into dy by dx of cos x. What we are applying here, dy by dx of uv formula we are applying here. Already we know that d by dx of is nothing but d by dx of u into v d by dx of, for the same formula we are applying, we will get d by dx of 1 by cos square x. Therefore, 1 by cos square x into cos square x plus sin square x. Here two types is there. First one is 1 by cos square x into cos square x plus sin square x. This one written as we are multiplied this both terms and denominator cos square x divided by cos square x plus sin square x by sin square x. Therefore, we will get cos square x divided by cos square x plus sin square x by sin square x. We will get 1 by tan square x. In this trigonometry, second identity we are applied here 1 plus tan square x. Therefore, dy by dx of tan x equal to, we will get secant square x. Same way, the second method 1 by cos square x into cos square x plus sin square x equal to 1. We know that 1 by cos square x equal to, this is the reciprocal of secant square x. So this is the formula of the, whenever we are apply the differentiations of the tan x, we will get secant square of the x. So this is the very easy problem. But here dy by dx of 1 by cos square x into, we are apply d by dx of u by view formula, we are apply 1 by cos square x into cos square x plus sin square x. Here cos square x plus sin square x value 1, therefore 1 by cos square x equal to 1, therefore 1 by cos square x is written as secant square x. Therefore dy by dx of tan x equal to secant square x. So this is the differentiations of the dy by dx of the tan x. So these are very important. So next one is y equal to sin inverse of x belongs to minus 1 comma 1. This point is will satisfy the y equal to sin inverse of x equal to, wherever y equal to sin inverse of x will be written as sin inverse of x is nothing but x equal to sin y. Therefore sin is transposed to right answer, will get y equal to sin inverse of x. Therefore x equal to sin y. In terms of dx by dy, we are apply here, we will get cos y. We are apply here actually in terms of y, that's why we will get cos y. Therefore minus 1 less than x less than y. Therefore minus 1 pi by 2 less than y pi by 2. Therefore y value is between minus pi by 2 and pi by 2. Therefore dx by dy equal to cos y greater than 0. Therefore dy by dx equal to the inverse of 1 by root of 1 minus sin square y in terms of y. Therefore d by dx of sin inverse of x in terms of, we are get value 1 by root of 1 minus x square. Actually given condition is dy by dx of sin inverse of x equal to 1 by root of 1 minus x square. This is the proof of the y equal to sin inverse of the x. Next value is y equal to cos inverse of x will be less than x equal to cos y. Therefore x equal to cos y, the dy by dx of the minus sin y, dy by dx of 1 by minus sin y. How do we get x equal to cos y? Therefore d by dx of 1 by sin y is nothing but, we are apply the formula differentiation, dy by dx of equal to cos is nothing but minus sin x in terms of sin y. But here asking question is in terms of reciprocal cos inverse of x. That's why this reciprocal value is 1 by minus sin y. Therefore we will get minus 1 by sin y. Therefore minus 1 divided by root of sin y value is root of 1 minus sin cos square y. In terms of x, 1 by divided by root of 1 minus x square. We are applied differentiation. This is the formula d by dx of cos of x in equal to minus 1 divided by root of 1 minus x square. This is the formula proof. This both formulas very easy formula.